Hi there, welcome to this fourth video in the yt-napari tutorial series. Today we'll be talking about how to use the JSON file loader that comes with yt-napari. So we'll go over how to write declarative JSON files with help from a schema, and then we'll write some yt-napari JSONs to load samples from regions, from slices, and then we'll also do a bit of sampling of time series. Requirements for this video, mostly the same as all the other tutorials, so we'll use a virtual environment that we created in previous videos, so go back to the first video if you need a hand setting that up. This tutorial in particular will require currently the latest version of yt-napari, which is 0.2.0, in order to do some of the time series sampling that we'll do. And then this tutorial in particular, I'm going to be using VSCode for writing the JSON files because it's got a really nice interface for writing JSON files that gives you lots of hints for how to fill out the JSON. There are other tools that can do this for you, so it's not really required, or you can just use a plain text editor for everything that we will do, but I'll be using it, so I do recommend that you use it as well for writing JSON files because it's pretty awesome. And then finally, in terms of sample data, this video is going to use the deeply nested zoom as well as the Enzo tiny cosmology dataset from the YT sample data repository here. So you can go click on or go to ytproject.org/data and download those data files if you want to use the same data files that I'm using here. And thanks again to CZI. Okay, so let's get started by opening up VSCode. And I'll do that from command line. You can alternatively click through and open up VSCode. We're going to be doing fairly little in VSCode, so all you need is an empty directory where you can create a file. Click that out. Great, and we're gonna open up a new file, so let's just hit that new file and we'll call this yt-napari _load regions .json, and we'll create that in the current directory. And great, so what we have here is our JSON file. So writing JSON files is very similar to writing dictionaries in Python with some minor differences, but one of the reasons to use VS Code, let me see if I can make this font bigger. Yeah, so one of the reasons to use VS Code is it gives really nice autocomplete with JSON files after you specify a schema. So to get started, let's open up brackets. And in VS Code, you can hit Control Space to pop up suggestions for the different fields that you can write. Hit Enter to accept that. And so the schema here is going to be going to describe what you can put into the JSON file. So it's what VS Code will read from to give you your hints as you go. So what we want to do here is point to the yt-napari JSON schema. And so to do that, we're going to go to the yt-napari docs page. And down here we have this entry for the yt-napari JSON schema. Click on that. And so this is what the schema actually looks like. Don't need to actually look at it in detail though. The raw JSON file is available there, so you can click on that link and just copy that web address. And then this is what we put into our entry here. And so now we add a comma, go to the next line, and now when we hit Control Space, we'll get more type hints that come directly from the yt-napari schema. So two broad categories of how to use the JSON schema. You can either load single data sets and sample from them. With yt-napari 0.2 and greater, you can actually do some time series sampling across different time steps from a data series. So first, let's start with just sampling a single data set here. So when you hit Control Space, you can go up and down to select which one you want. And I just hit enter to select data sets, and that opens up a list in brackets because you can supply multiple data sets. We hit Control Space again and open up a new object, hit enter, Control Space, and now we get into where we're specifying what we want to do. So we're going to specify both the file name, so this refers to the data set we want to load, and then the selections, which is what we want to load from that. The final option here, store in cache, controls some of the backend behavior of yt-napari, so that if you're loading the same data set multiple times within a Napari session, it'll preserve that yt data object so that you don't have to rebuild the index continuously. We're not going to touch that, but in any case, let's specify a file name. So for this one, let's use a different data set from what we've used in previous videos. So we're going to use the deeply nested zoom data set. And that time step is DD00250025, and then data 0025. Let's add some selections. So again, that's Control Space to bring up the options, hit enter to select the selections key, and we're going to define some selections here. So within the selections, you have two options. You can either do regions or slices. We will do regions for this first example, and again, we have a list because you can load multiple regions. So let's do Control Space again to define a region that we want to add. So these are all the fields that you can specify for loading a region. The fields are required, and we're going to add 2 fields. So let's start with, so for each field you have to specify the field name and field type. So let's start with the field type, and let's do gas, and then field name of density, and comma at the end here, field type gas, field name temperature. So we're going to load a temperature and a density field here. So that's all the fields. And then the remainder of the options here, left edge, right edge, resolution. So those just define the bounding box and the resolution you want to sample at. Initially, though, we're not going to specify those fields. So this will be a sample of the whole data set. And as a note as to how writing JSON files differs from standard Python dictionaries, so in JSON files you cannot have trailing commas like this, so you'll get an error if you leave that there. But luckily VSCode has highlighted that to remind us. Cool. So this is the minimum you need to do to load in some fields. So let's save that file, and then we're ready to open up Napari. So first off, let's activate the environment that you have Napari and yt-napari installed into. Oops. There we go. And then load up the Napari GUI. Right, so all you need to do to open this JSON file is to go to specify or file open files, and then in the current directory, tutorial 4 for me, there's this JSON file that we've been writing. So we just hit open and check out the terminal, how it's going through the normal YT loading procedure. The first time you do this, it might take a little bit, but that was actually pretty fast. Cool. Right, so we have our two fields that we selected here. Gas temperature, our view right now is 2D view. Temperature field is on top, and occluding the density field, so let's unclick that to see some differences there. And that's real quick. Just take a look at the 3D view here. Cool, so this is our deeply nested zoom dataset where there's some AMR grids in the outer coarse AMR grids and some pretty high resolution AMR grids in the middle. So that you see, so in this though, when you zoom all the way in, this is pretty coarse still, and it's much coarser than the available resolution. So let's say we want to add another domain to sample within this, a box that's centered around here, but we actually want to keep the overall coarse layers here. So we'll go back to our JSON file and add some stuff to it. And I'm actually going to delete these and they'll get resampled. You could alternatively just start modifying this single region and then load the same file again and it'll add the new layers, but I'm going to just resample every time. So this is the end of our first region, so let's add another region. In this case, the fields, these are going to be the same, so I'm going to go up and copy and paste our temperature and density fields. And this time we are going to specify the left edge. And for this you have to give it a value, optionally a unit. If you don't supply a unit, it's assumed to be in code length. So let's have a smaller box just around the center. And let's also specify our right edge. Great, so we have our left edge, our right edge, our fields, and just for fun, let's actually add a third region here. So I'm going to copy this region entirely, add a comma, paste it again, and just for fun, let's just add a oddly shaped box here just to see what happens. Actually, let's start all those at the same place and change the right edge to 0.8, 0.9, 1.0. Okay, so now we have our three regions, all loading the same fields, and we can save that and go back to Napari, hit open files, and then load regions again. And sometimes it does hang here a little bit. This because the implementation of the loading function right now for the file loader is not in a separate thread, so you gotta wait until it completes sometimes. But once you do, you'll get an image like this. So we now have our 6 layers. So we have 3 layers per field for the 3 different boxes here. So first off, let's just hide all of our temperature fields. So right now we're just looking at density, and you see that we now have our interior high resolution box, the coarser box, and then our strange oddly shaped box over in the corner here. And when you load in these in as separate layers initially, they are scaled independently. So let's actually link our layers here. So I'm gonna click the first layer, control click the other 2 density layers, right click, link. And now when you make changes to one layer, it'll make changes to all of them. So first, you can right click the contrast limits up here and hit reset, and it'll rescale to the full data range across all of the boxes. Let's actually modify modify that a little bit. Temperature. Let's go. Okay. So the scale bar was being a little funny there. And now when we change our limits, you can see it's applied to all of the boxes, so that things are scaled. And you can see really nicely how the inner high resolution box is sampled at a higher rate, closer to the actual available resolution. So let's unlink these. So this is the high res box, and you can see how unclicking it you get the initial coarse sampling, and then switching back to displaying it, you see the higher res sampling. Yeah, cool. So that's how you load in regions, and that's all. That's about all for the regions. So let's get rid of these. Minimize Napari again. And we're going to start a new JSON file, but I'm going to copy the schema line here. Okay, so here's our new JSON file. Let's open up our brackets, and I'm going to copy paste the schema line that we have from the other JSON, comma, and then control space to open up our data sets. Control space again to specify our data set, and we're going to use the same data set as before. So it's the deeply nested zoom, and VSCode nicely remembers what we've been typing here. So you can also do the control space on the different parts of the file path, which is pretty convenient. And now that we've specified our file, we're going to specify our selections here. And instead of regions, we'll do slices. And similar to specifying regions, we specify our fields and then all of the parameters that control how the slice gets loaded in. So for our fields, let's just load the density field in this case. So field type, gas, field name, we'll do density, and control space to bring up the other options. Actually, as a side note here, when you bring up the control space to see the options here, you can actually click on. Oops. Let's bring that back. When you click on the right arrow over here, it pulls up the help for that field. So there's a little, tells you what the actual field corresponds to. Cool. Anyway, let's actually specify something now. So slice height, we will set to 0.2, and slice width, we'll also do a value of 0.2. And let's actually add another field in here. Oops. Okay. And we'll just add the one slice. You could add multiple slices like in the regions, but let's just do the one. So save that file, open slices, and you actually see we got an error, probably because I mistyped something. So when you get an error with the JSON file loader, you generally have to zoom up pretty far to find what went wrong. And so we are missing a normal axis here. So let's go specify that, because we are doing a slice. So normal x, save, let's go try again. And there we go. Oh, I selected the wrong one. Slices. Okay. Slices load much faster. That explains that. And we are actually looking at our slices here in 2D or 3D, but let's switch to 2D. So we have our temperature and density, and we talked about this in the video about using the Jupyter Notebook interface, but one of the fun things to do with the when you load in slices into Napari is to create composites of fields. So right now our temperature field is opaque and overlying our density field, so you can only see the temperatures. So let's give it a different color map. So let's make the densities red, temperatures yellow. Let's actually move the density up top, and you can either make the top layer opaque and you'll get kind of a blending of the two. You can also make an additive lot, or you can change the blending to additive to simply add the RGB values. And the red and green is kind of nice because you can actually see the points where they do not overlap very much. But in any case, that's how you load in slices. And let's clear that out and go do yet another JSON. So again, I'm going to scroll up, copy the schema, new file, new JSON file, and we are going to do a time series sample here. Okay, open brackets, paste in our JSON schema, control space again, and this time we're actually going to do the time series specification. So first off, the top level here, so we have a file selection. So this is how you specify what files you want to treat as part of a data series, and then some other options here. And let's start with the file selection. So for this, we're going to use the Enzo Tiny Cosmology dataset. And so we can specify things in a number of ways. The directory is a string that will get added to the start of any of the rest of the entries that we have here. So let's just type our tiny cosmology. So that's going to be our top level directory. And then you have a couple of options. So the file pattern, very similar to the specification in yt's data series objects. So so this is any string that you want. So normally these tiny cosmology data files look something like this. So this would be the 40th time step that we have available, and so you can add some wildcards to select all of the data sets that are available. You can, instead of that, you can explicitly list the files you want using this file list parameter. You can either use file pattern or file list. With both of those, you can use this file range as well. So what this lets you do is specify essentially a Python range that will be applied to any of the files that get picked up. So let's say we wanted to sample of the files that'll get matched here. There's 40 something time steps here, so let's just sample from 0 to 40 to in increments of 10. So we should just pick up 4 of the time steps here. And then, so that's our actual time step selection. And then we need to go and actually apply a selection of some kind. So just like the regions and slices before, you can do that with the time series. So in this case, the region or slice will get applied to each time step that gets matched. And let's do this. So we're only going to have 4, so we can actually do a 3D region here. Okay. Left edge. Oh, let's just do the whole domain here. So let's just specify our fields. And we'll do our gas density field again. And so sample the whole domain. Let's get rid of our little help here. So the resolution is pretty important when you're loading in time series. So with the JSON file loader, everything will happen in memory. So if you're loading a bunch of time steps at pretty high resolution, you can easily exceed the memory available on your computer. So we're only loading in 4 time steps here, so it's not going to be too bad, but I'm still going to drop this resolution just so it goes up a little bit quicker. With the JSON file loader, Napari will kind of like hang out while the selections happen, so you're kind of stuck there waiting for things to finish. In some future videos, I'll walk through how to use the time series loader from the GUI, and that happens in a separate thread, so you're not stuck waiting for the data to load. And then there's also, you can also do this from a Jupyter notebook. So there's an interface for loading time series there, and in that case, you can actually use Dask to lazily load in the different time steps. So if you're working with large amounts of data, I'd say the Jupyter notebook is probably the way to go here. But in any case, let's see what happens when we load in this time series. So let's select our time series file and hang out while it goes and samples our 4 time steps, and we get out our density layers. So these are density at 4 different time steps here. We're currently in a 3D view here, and let's unclick so that we're only seeing one at a time here. So this is the latest time step, and then you can load in slightly earlier one, and let's go back even farther so you can kind of see how the density field here is coalescing into a network. Let's get rid of those and go back to VSCode. So one of the other options that's fun to use here is this lotusstack. So if you set this to true and then go back and reload, instead of opening all your selections as separate layers, time series, it'll sample all the different time steps and then create a four-dimensional array that gets loaded into Napari. So now we're in our 3D view here, and so this slice here is, or the slicer down here is actually goes through time. So now we can actually step through our time evolution. Yeah. And oh, one kind of cool thing that I wanted to mention that I don't think I've shown in other videos is this depiction option here between volume and plane. If you select plane, you actually get a slicing plane, and you can, let's adjust the contrast on this. So you can actually click that plane or shift click, and as you then drag, it'll drag the plane through your 3D volume, which is kind of a fun way to check out a 2D slice through your volume. When you switch back down to 2D, since we have a 4D array, you'll actually have two sliders down at the bottom. The first one steps you through space, and the second one here is through time. So let's see if we can isolate one of these high density regions. Yeah, so you can kind of see these two high density regions down there merging together in time. Cool. Yeah, and as I said, the Jupyter Notebook interface actually gives you a bit more control over the time series sampling, so that you can, for example, specify a certain region you want to track through time. So it's definitely a bit more. You have a bit more control with the Jupyter interface than you do with the JSON loader, but it's a nice way to quickly load in the time steps that you want to check out. Yeah, so that was the last thing I wanted to show. Let's close off Napari. And just the last note I'll make is, now that we've loaded in some slices, regions, and time series, we now have these 3 JSON files that we've created, and these are a nice record of what you've done in terms of which data you've actually loaded in to start off your visualization. So it's a really nice way to kind of save where you started, or share with other people how to initially load in and sample your data. So it's a nice way to maintain some reproducibility between your sessions. So thanks. Quick summary of what we've done. So we've used VSCode to load in some regions using the yt-napari JSON schema that we specified. Let me actually zoom out here so we can get a better sense for our whole file. Yeah, so we have our regions, our slices, and our time series file. They all use the same schema. They point to the yt-napari schema. One thing I will note is that these schemas are pinned to the yt-napari version that you're running. Since we're in kind of early development still, there are occasionally breaking changes with the schema. So generally, if you're using a schema that differs from the version of yt-napari, you'll get an error message that'll tell you to update. But in any case, so in all 3 of our files, we have specified our schema, and then generally you provide it with the data you want to load, and then specify how you want to actually sample that data. And in the case of the slices and regions, those are applied to the single file that you have specified, the time series. You can specify matching patterns to pick up multiple files corresponding to a YT data series. And then from within Napari, you just load in these JSON files as you would any image file. So that's all we have in this video. Next video, we'll walk through the GUI-based loaders and then do a more in-depth look at loading time series through the Jupyter Notebook interface. So stay tuned.